stoichiometry, and this is called mass-to-mass stoichiometry. This is going to be our most challenging type of stoichiometry. So hopefully you've already watched the previous 3 videos. This one incorporates all of those other videos into one video and shows you how to do the most complex type of stoichiometry, which is starting with the mass of a reactant or product and finding the mass of another reactant or product. And that's why it's called mass-to-mass stoichiometry. So once again, I'm going to be using this example. If I had 4 moles of NH3 or 4 moles of ammonia, and I added exactly 3 moles of oxygen, I would make 2 moles of nitrogen and 6 moles of water. So the question is, if I gave you 42.5 grams of ammonia to start with, how many grams, or what is the mass of the water that would be produced? So starting with this, I want to know how many grams of this I'm going to make. This type of stoichiometry requires 3 steps. There is no shortcut. You have to do 3 individual steps. The first step is to convert grams to moles. As always, you don't want to start with mass. You always want to convert it into moles, because these coefficients, the 4, the 3, the 2, and the 6, they are related to moles, not related to grams. So, starting with 42.5 grams of ammonia, notice I put it under the ammonia, I'm going to convert it into moles. We've done this before. The molar mass of ammonia is 17 because N weighs 14 and each hydrogen weighs 1, so 14 plus 3 gives me 17 because there are 3 H's. If I do my conversion factor, or my 3-line method, 42.5 times 1 over 17, the grams will cancel, and I'll have 2.5 moles of ammonia as my answer. So now this 42.5 grams of ammonia has been converted into 2.5 moles of ammonia. Now what I'm going to do is I'm going to do a proportion step, a ratio. Now that I have the moles of ammonia, I can then convert it into moles of water. So I'm going to set my ratio of 4 to 6. And that's what I did down here. 4 moles of ammonia is equivalent to 6 moles of water. However, I don't really have 4 moles of ammonia. I only have 2.5 moles of ammonia. So here's where my proportion, or my ratio, comes in. 4 moles of ammonia over 2.5 moles of ammonia is equal to 6 moles of water over X. And when I solve for X, I get 3.75 moles of water. Now the final step is I have to convert moles of water back into grams. So I'm going to do almost the same thing I did in step 1, but I'm going to do it in reverse. Instead of going from grams to moles, I'm going to go from moles to grams. So here's how I do it. I take the 3.75 moles of water. The molar mass of water is 18 grams per mole. Notice I condensed a little bit here. I should have done it like this, but I didn't have enough space there, like that, per 1 mole. So then the moles of water will cancel. So 3.75 times 18, and again 18 is the molar mass of water, gives me a final answer of 67.5. Now, let me show you the whole thing as one picture. Here was the original reaction. 4NH3 plus 3O2 goes to 2N2 and 6H2O. And here is what I started with, 42.5 grams of ammonia. Step 1, I converted grams to moles by just doing a conversion, and I got 2.5 moles of ammonia. Step 2 is I did a ratio. My ratio of ammonia to water was 4 to 6, so 4 over 2.5 equals 6 over X, and X worked out to be 3.75. And then finally, I converted moles back into grams by once again converting moles into grams this time instead of the other way around, and that turned into 67.5 grams of water. As you can see, this is the most challenging type of stoichiometry. It requires 3 steps, but it's still very doable. And often the ratios are so simple that you can usually do the ratios in your head. This one I couldn't. I actually needed a calculator to do a 4 to 6 ratio. but most of the time the ratio step is really simple. There are even some situations where the ratios are 1-to-1 because the moles of reactant and product are the same moles. So that makes it easier. If you have any questions, please talk to me in class. As always, you should pause this video, maybe go back, watch it again, take some notes.